Chapter 9, Hypothesis Testing for One Population Mean. This first section we're going to talk about nature of hypothesis testing, mostly going to be vocabulary and terminology. What are we talking about, what we need to do. We'll get into more of the nitty-gritty of doing hypothesis testing in the next couple sections. So, in Chapter 8, we looked at confidence intervals. We said here's this interval of values where I am pretty confident, I'm 99%, 95%, 90% confident that the population mean is within this interval. In this case, we're chapter hypothesis testing. We are just going to be making a decision. Do I accept this or do I reject this? How do we make decisions when we're looking at these statistics and we're working with the hypothesis test? Hypothesis, we worked with those in science before. Hypothesis, your educated guess. In this case, we're going to say a hypothesis is a statement that something is true. And when we do our hypothesis testing, we're going to have two of them, not just one, two. So we're going to have our null hypothesis and an alternative hypothesis. So, the null hypothesis we will represent with H sub 0. The alternative hypothesis is, okay, we're testing the null hypothesis. This is what we have. The alternative hypothesis, this is something we say, or it could be this one. We're going to use H sub A for that. And the test is where we decide whether or not to reject the null hypothesis in favor of the alternative. When we're dealing with math and logic and proving things, it is so much easier to prove something is false than to prove it is true. In order to prove the null hypothesis, we would have to show that we were 100% positive that we are correct on that. And really the only way we can do that is with a census. And we're doing this inferential statistics because the census is not feasible for whatever reason. To prove something false, you just have to show one example of it being false. So if it fails at one point, we can say it's not necessarily true, because if it's true, it's always true. So if it fails once, we can reject it. But all we're doing in the hypothesis test is saying, can we reject it in favor of this alternative, or can we not reject it? Which doesn't necessarily mean, yeah, it's perfect. Okay. So our first step is we need to find H sub 0 and H sub A. So with these guidelines, and what we're going to talk about, we're focusing on a one mean parameter hypothesis test. Now, any hypothesis test with just one parameter, we can use these guidelines on. If we have more than one parameter, then we need something else. We're just going to focus on the one. We're working with the mean, so when we're doing a one population mean, the null hypothesis is always going to be mu equals some number. Now, this is some number that we're trying to prove is correct. This is not necessarily what we got from our sample. This is what we're doing before we get to thinking about our sample. What do we think it's going to be? Now, for the alternative, what our alternative looks like depends on what kind of a test we're going to be doing. Two-tailed, a left-tailed, or a right-tailed. Kind of makes sense. We've been dealing with right-tailed, left-tailed, and two-tailed all this time, talking about distributions. That's what we were leading up to right here. So a two-tailed test is if we want to say, hey, your mean is something else. It does not equal mu sub 0. So if we're saying the H sub A, our alternative hypothesis, is your mu is not your mu sub 0, then you would do a two-tailed test. If we want to get more specific, we want to say, hey, the actual mu is less than my mu sub 0, then I'm going to do a left-tailed test. And if I want mu is greater than mu sub 0, I'm going to do a right-tailed test. So your alternative hypothesis for this one mean hypothesis one mean hypothesis testing is going to be one of those three. and which test we use is determined by which of these we use. So, take a look at these situations and see if you can do these, and then I'll talk through them. Making pretzels, 454-gram bag of pretzels. Weight, actual net weight varies. We know this, it says it on every bag, right? Company says that the mean weight is 454. Quality assurance, we want to see, is it 454 or not? So determine the null hypothesis, the alternative hypothesis, and tell me what kind of a test you're going to do. Null hypothesis. H sub 0 is 454 grams. Let's make that a little smaller. Again, your null hypothesis is always going to be a single value. What do you think it should be? The alternative hypothesis. We're just trying to decide, is it 454 or not? So we're going to say our H sub A is going to be mu does not equal 454. Since we're saying does not equal, this is going to be a two-tailed test. Let's look at the next example. About half century ago, they found the average U.S. woman in her 20s was 62.6 inches tall. We want to say, we have gotten taller in the past half century. So we want to say now that the average woman's height is taller than 62.6 inches. So again, what's your null hypothesis? What's your alternative hypothesis? Is this two-tailed, left-tailed, or right-tailed? Null hypothesis, mu equals 62.6. Alternate hypothesis. We say they're going to be bigger, so we're going to say mu is actually bigger than 62.6 inches. And since we're going bigger, that's going to be right-tailed. Poverty in dietary calcium. In this case, we say that recommended adequate intake of calcium is 1,000 milligrams per day. We want to do a test to see if the average adult with an income below the poverty level is less than that rating of 1,000 milligrams per day. So what's your null hypothesis? What's your alternative hypothesis? And what kind of a test are you doing? Whoops, jumping ahead of myself. Null hypothesis, mu equals 1,000. Alternate hypothesis, mu is less than 1,000. We're less than, so we're going to go to the left-tailed. So these are situations where we would use these different type of hypothesis testing on here. So once we figured out what H sub 0 is and H sub A is, we're going to need to determine to do this test. We're going to need a test statistic to do this. We will work with more how do we make the decisions, where does this come from. We'll look at that in sections 2 and 3. But for right now, we're just kind of setting up this situation, what we're doing. Now, we can always make mistakes. So, we have two options. Either the null hypothesis is true or is false. And then we have two decisions. We either reject it or we do not reject it. So, if it's actually true and we don't reject it, we were right. If it's actually false and we reject it, we were right. Otherwise, we made an error. And we classify these as type 1 and type 2. So a type 1 error is it's really true, but we rejected it. And a type 2 is it's really false, but we didn't reject it. And you could just say you're wrong is wrong. Does it make a difference if you're just, is being wrong, is it just bad enough you're wrong? Well, let's take a look. If my hypothesis says here is I have this person coming in and they think they have the flu. And I'm going to do a test to see if I accept the fact that, or if I reject the fact that they have the flu, or I don't reject it and maybe they do have it. So I'm going to do my test and I'm going to make my assumption here. So if they do have the flu and my test says, hey, don't reject my null hypothesis is that they don't have the flu, I made a correct decision. But if I make they have the flu and I reject that and I say they don't have the flu, that's a type 1 error. In this case, they don't have the flu. I reject my hypothesis that they do. I'm right. But they don't have the flu. I don't reject it. So I say, yeah, I can't say you don't have the flu, so you might have it. That's a type 2 error. Is there a difference? Well, with the type 2 error here, I don't have the flu, but I'm getting some treatment and I'm taking my care of myself just in case I do have the flu. That's not too bad. Flu treatment isn't too bad. Now, if it was kind of like, oh, should we cut off your arm or not? That might be a different situation. But if you look over here, I do have the flu, but I rejected that. I made this error. Then I walk out of there. I have the flu. I'm contagious. I can give it to other people. I'm not taking myself. I can get taking care of myself. I could get sicker. This is much more serious than the type 2 error. Now, is it always that way? It depends on how you're defining your null hypothesis and your alternate hypothesis, which one is worse. But that's why we distinguish between a type 1 and a type 2 error. So, looking at the pretzel packaging plant, if my mu was 454 grams, if that's my H sub 0, my H sub A is mu is not 454 grams. If I have a type 1 error, that means it is really 454. Everything's working right, but I think I'm rejecting it. I'm saying, hey, it's not that case. So what am I going to do? I'm going to do standard maintenance. I'm going to double check everything to make sure it's working. That's going to lose me a little money on the shutdown time, but in all, I'm double checking things. Maybe that's not a bad idea to do. A type 2 error. Type 2 error says, I really am saying that really my mean is not 454. I'm either putting too much in the bags or I'm not putting enough in there. But I'm blissfully unaware. I think everything's working perfectly. I say, hey, I can't reject that it's 454. So I go on and I'm either going to be overfilling bags, which is losing profit, or I'm going to be underfilling bags, which is going to getting people mad at me. So that's important. Correct decision is either, hey, it is 454, and I say, yep, it's 454, or it's not 54, and I say, yeah, it's not 454, I'm going to take that one. So, if the mean weight really is 454, and I rejected the null hypothesis, that means I made a type 1 error. If the mean weight is not 454 grams and I rejected the null hypothesis, that means I made the correct decision. So that's, again, classifying your errors. And it makes a difference whether it's a type 1 or a type 2. So that's why we do spend some time with that vocabulary there. Other reason we do this is we talk about the error probability. So the probability that we made a type 1 error, we will call that alpha. And that's called the significance level of our hypothesis test is based on the type 1 error, the alpha. The probability of making a type 2 error is denoted by beta. Generally, alpha is the one we're most concerned about, because again, that's the significance level of our hypothesis test. But again, they're inversely related. For a fixed sample size, the smaller alpha is, the larger beta will be. So the tighter we make that significance of the smaller that level, the less likely it is to make a type 1 error, the more likely we are to make a type 2 error. So that's one of the things, as we're adjusting that, we got to look again at what's most important. Which of those errors is the one that we want to avoid the most? So, again, hypothesis test, we have a small significance level. If the null hypothesis is rejected, we will conclude the data is sufficient to support the alternative hypothesis. We don't say the alternative hypothesis is true. We just say we have enough evidence to say the null hypothesis is false. And we kind of support the alternate. If the null hypothesis is not rejected, we just say we don't have enough data to support the alternative. Again, it does not guarantee the null is correct. We just don't have enough data to say, hey, I'm going to take the alternate instead of the null. So again, we're hedging our bets a lot. Again, we're trying to prove something wrong because it's easier to prove something wrong than to prove something right. So here are some problems to work on. Enjoy.